Every single year, humanity consumes more than 5.5 million tons of tilapia. More than salmon, more than tuna. It's the most widely eaten fish on Earth, a humble freshwater species that somehow feeds millions across every continent. But few know where this fish really comes from, or how one unassuming species became the backbone of a $10 billion global industry. Today, we dive deep inside the giant tilapia factories of China, where biology meets technology, and where fish farming has transformed into a world of sensors, algorithms, and machines. A system so advanced it no longer looks like farming at all, but manufacturing life itself. From broodstock to billions. Every story begins with a foundation. For tilapia, that foundation is broodstock, the parent fish carefully chosen to shape the next generation. These aren't ordinary fish. They are the elite, bred, monitored, and even genetically refined to grow faster, resist disease, and produce offspring that are nearly identical in size and shape. In specialized hatcheries across China, scientists cross strains of tilapia, the way engineers refine engines, selecting only those with ideal traits for global farming. A single female can produce thousands of eggs in one season, but nature adds its own twist. Tilapia mothers carry their fertilized eggs in their mouths. It's a behavior called mouth brooding, a natural instinct that protects the next generation from harm. In industrial hatcheries, this instinct is harnessed with precision. Eggs are gently collected, placed into temperature-controlled incubators, and monitored by AI systems that fine-tune oxygen, temperature, and water flow to perfection. The result? Survival rates that soar from just 70% in the wild to over 90% in these high-tech nurseries. One hatchery in Guangdong, powered by machine learning, produces over 200 million baby fish every year, enough to fill entire provinces with life. Smart farms, where AI meets aquaculture. Once the fry leave their nursery tanks, they enter a world that looks less like a pond and more like a laboratory disguised as water. Welcome to the era of smart farms. Here, fish don't speak, but their environment does. A network of underwater sensors constantly monitors oxygen, pH, temperature, and ammonia. Each reading is a signal, and those signals feed into a living algorithm that decides when to feed, when to filter, and when to rest. In Hainan Province, AI-driven feeding systems use underwater cameras to watch the fish eat. When the tilapia slow down or stop rising, the system cuts the feed instantly, reducing waste by nearly 20% and saving thousands of dollars every season. Soft mechanical sounds, water splashing, conveyor hums. Machine learning models even detect subtle changes in swimming behavior, predicting early signs of disease before farmers ever notice. By catching problems early, antibiotic use has dropped by 30%, a win for both cost and sustainability. The numbers are staggering. A traditional pond might yield 1 ton of fish per acre, but in these recirculating smart systems, that number climbs to 4 tons, while recycling up to 85% of the same water. This isn't just fish farming, it's precision aquaculture, feeding millions the science of growth. Technology alone doesn't raise fish. Life needs nutrition, balance, and care. Each tilapia consumes a meticulously engineered diet, a blend of plant proteins, vitamins, and minerals, designed to maximize growth and minimize waste. Unlike salmon or tuna, tilapia thrive on a mostly plant-based diet, making them one of the world's most sustainable farm species. In a single day, a large farm could dispense 10 tons of feed. Smart feeders release food only when cameras confirm active feeding, keeping the water clear and oxygen levels stable. Meanwhile, farmers test the water daily, balancing pH with lime, injecting oxygen to reduce stress, and adding probiotics instead of antibiotics to strengthen immunity. In Guangdong, one high-density farm reported survival rates above 95%. The secret isn't just technology, it's discipline. Because in aquaculture, biology always has the final word. Harvesting armies of fish. After months of growth, millions of fish are ready for harvest. And this is where the process shifts from farming to engineering. Harvest Day is a military operation. In older ponds, workers still wade in with nets, a laborious, risky method. But on China's industrial farms, giant harvesting machines can lift 12,000 kilograms of fish per hour, gently moving them through water-filled pipes into oxygenated tanks. Timing is everything. Too long in a crowded tank, and oxygen drops fast. So many farms now synchronize every harvest with real-time transport schedules. Oxygen levels are tracked inside trucks through mobile sensors, ensuring every fish arrives alive, fresh, and stress-free. This is logistics at the scale of biology, a choreography of water, machines, and living cargo. Inside the processing giants. Once harvested, the tilapia enter the most advanced phase of all, the processing plants. Here, the transformation from fish to food begins. In vast stainless steel halls, thousands of fish move through automated lines, stunned, cleaned, and filleted in seconds. X-ray scanners inspect every fillet for hidden bones. High-speed blades glide with surgical precision, while human workers check each piece for texture and color. Consistency is key. Every fillet must weigh the same, look the same, and be ready for the world market. To ensure trust, some plants use blockchain tracking, tagging each batch from pond to freezer, so a restaurant in California or a supermarket in Lagos can trace exactly where their fish was born. The final step is freezing. Each fillet vacuum sealed and IQF frozen at -40 degrees Celsius, locking in freshness within minutes. Within hours, pallets are loaded into refrigerated containers, heading to ports that ship to over 100 countries. China now supplies nearly 70% of the world's tilapia exports, from tacos in Los Angeles to steamed fish in Nairobi. This once local species now sustains tables around the world. Beyond the factory, the future of food. But the story doesn't end at the factory gates. Tilapia farming fuels a $10 billion economy and supports millions of families across Asia, Africa, and Latin America. For many, it's more than work. It's survival. And in a world of growing populations and shrinking resources, tilapia represents something even greater, a blueprint for sustainable food production. Unlike predators like salmon or tuna, tilapia require no fish meal, just plants, water, and human ingenuity. As artificial intelligence, automation, and eco-certification evolve, aquaculture stands at a crossroads, one that could either exploit the oceans or protect them. The humble tilapia may not be glamorous, but its story, from gene-edited broodstock to automated harvesters and frozen fillets, reveals something extraordinary about us. Our endless drive to feed the world, one fish at a time.